All right, I'm going to see if I can get the review-ish video together for you to see if this helps. First things first, let's see if we can just review a couple of inequality, just general things that you need to remember. I'll switch this back to black for you. Then I'll put some little picture on the side of each one so that you kind of know what I'm talking about. First things first, as far as your symbols are concerned, you may have a less than symbol or a greater than symbol. There's nothing else extra to them. It's just a less than symbol or a greater than symbol. If I were to graph these, they would be dashed lines. They are dashed lines. That line is called a boundary line. And if I were graphing it on my coordinate plane, it might look like this. It's going to be dashed. If I have a less than or equal to symbol or a greater than or equal to symbol, that is going to be not on a dashed line, but that equal to means that it includes it. So it's going to be on a solid line. I will highlight and color code these in just a second for you too so that you can see, but this one might be, we'll put it in the other direction. This one is going to be a solid line being graphed. So we'll do dash line less than or greater than is dashed. That's this piece here. I'll get rid of the highlight in just a second too so that you aren't getting overwhelmed. But then you have less than or equal to, and greater than or equal to is a solid line. That graph might look something like this. You've got dashed lines and solid lines. There we go. Your dashed lines are for when they are just less than or just greater than. Your solid lines are for when they are including the equals to. Something else you might see is when we're graphing these inequalities, you're seeing whether they're shaded or not. So if you see a less than or equal to thing, it is being shaded below because it's less than, it's lower, it's less than, it's below the line. Shade below the line. And if you see greater or greater than and equal to, greater is higher, it's rising, it's shaded above the line. I'm going to do a ton of examples. This video might actually be a little long, and I'm sorry, but I'd rather you have too many examples than not enough of deciding where we shade. Things are slightly different when they are vertical lines because then you're kind of looking at like a number line. The greater than things are to the right, your less than less to the left. The last thing that we need to talk about in an inequality are your solutions. Solutions are points that are either in the shaded area. So if there's shading, when we shade one a little bit, I'll put some polka dots in it. Those will be different points that could be included. Those are all different solutions. So they're either points in the shaded area or points that are on the solid line. Not on the dashed line. It must be a solid line because, like we said, solid has the equals to, so that means it's being included. I'll leave this here for you to pause so you can do what you gotta do. There's a slightly neater version without the pictures here to pause me if you need me there. Otherwise, let's graph some of these and get you to maybe hopefully be able to see it a little bit better if we are physically graphing it. I don't know why that little black dot's there. All right, so we will look at the green equation first. The green equation, I'm going to put it down here just so that we can kind of analyze it. Taking it back to freshman year, we know that this is, for the most part, in slope-intercept form. Up at the top corner, I'll put y equals mx plus b. That was your slope-intercept form. It was the form you guys were the most comfortable with graphing. For the m, the coefficient, the number in front of the x, was your slope. And the b, that constant at the end, is your y-intercept, hence slope-intercept form. Here, that means that we know our y-intercept, the point the graph is going to cross the y-axis is at 3, or as a point that's written as 0, 3. And my slope is 2. Some people say 2 over 1 because you rise and you run in slope. So let's graph this as if we know nothing else. We're going to graph it like it's slope-intercept. We're going to come over here on our y-axis, up and down. We're going to put our first point at our y-intercept, which is at 0, 3, y-intercept of 3. And it says my slope is 2, 1, so I'm going to go up 2 to the right 1 from there. And just for funsies, so I have an extra point, I will go the opposite direction, down 2 and to the left 1. That gives me 3 points that I can connect. Now, going back to looking at the symbol included in our inequality, we see that it's a less than symbol, and it does not have the bar underneath. No bar, just a less than symbol. So since it does not have the bar, we know that the line, as crookedly as I just drew it, is going to be a dashed line. It's not going to be solid because there is no bar underneath. And it's an inequality, so we're going to shade it. When we shade it, it's less than, less is lower, so we're going to look at the line and shade below the line. So anything we shade in the y is going to be less than this. So all of these negative numbers down here, all of this stuff, like we said, since it's dashed, it doesn't actually quite include the things that are on the dashed line. Get as close as you can, but you know what you're kind of looking at. Anything on that dashed line is not included. At this point, if I wanted just solutions to the green graph, anything in these green points are going to be solutions for your equality. Then if we're looking at the red one, we can do that same thing. We know that our y-intercept here is 1, or the point 0, 1. It's still set up very nicely in y equals mx plus b, so that my slope, or my m, is 1/2. So I'm going to put my point at 1 on the y-intercept in red so that you can see the equation. And I'll go up 1 to the right 2. I'll do it twice. And now we look at this one and we see that it says greater than, it's opening to the y, it's greater than or equal to. It has that bar. That bar is the key. It has a line. That means this is going to be a solid line when we draw it. No dashes because it includes the equal to. And then we saw that it said, we'll make it yellow, orange is close to red. It says greater than, it opens out. Greater than, it's opening up. We're going to open and color in the color the way that it's faded. So we're going to go greater than this line. Anything that's greater than is going to get shaded in. So now if we wanted just some solutions to the red, we're going to look at anything that is in that orange section. But if we want solutions to the system, we want solutions to both of these things, we're actually going to look at any point. Let's see if I can make it yellow. At any point in here, all of these points or points on the solid line, all of these, they don't even have to be perfect. They can be decimal place points. They can be points on the origin. They can be in that little baby space down there where they meet. Any point that is in yellow right now, or any of the infinite amount of points that are in there, those are all considered solutions. I don't think if I write this in yellow, you'll see it, but we can try. Your solutions are in the overlap. I will do, I know this might be a little long, but I hope that it helps. I will do maybe 2 more. I know that I've done 2 of these with you guys in class, some of the same examples, but sometimes even just seeing it a second time will help. So let's say, actually this one's perfect because it has a vertical line and a horizontal line. These are not quite in mx plus b form. They're a little different. You might have remembered seeing Hoy bucks when you were younger. when they first taught you about this, horizontal lines have a zero slope or look like y equals, and vertical lines have an undefined slope. They're straight up and down. They're vertical, they're undefined, they look like x equals. That's what these are. These are just telling you, the red is telling you to look on your y axis like it's a number line and go to 2. And everything, any point that has y equals 2, those are all technically part of this line. And it's saying, all right, well, it has the equal to bar underneath, so it's going to be a solid line. And then as far as shading is concerned, we look here and we see greater than numbers on a y-axis, looking at it like a number line. If I want numbers that are greater than 2, I'm going to keep climbing higher and higher and higher until I get to the top. There is no top, but you know what I get at. So I'm going to shade everything higher and higher and higher and higher. Everything you need is up, going further. Looking at the x's, x equations, x equals something on my x axis, treating it like a number line. I want to look for x equals -4. 1, 2, 3, -4. And this one's saying that all of these points are going to ride up and down along x is equal to -4. All of this line, when you graph it, is going to be up and down. X is equal to -4. This one also says greater than or equal to, so the beauty of that means that it is also a solid line. When I'm going to shade that in, greater than -4 on the x number line, I'm looking at my number line, and I want things that are greater than -4. 0, 1, 2, 100, all of these numbers that are bigger than -4 are all going to be numbers to the right of -4, so I would shade in to the right of that line. Any of my solutions, let's do the solutions in purple this time. Any of my solutions are in the overlap. So any point, any single point that is in that overlap, anything here, including on the dot on these solid lines, because they are solid, and solid lines mean that they are included. The dots mean that there are holes, so obviously we can't count them, but we've got these solid lines, it means that they are included. So there could be solutions there. Solution could be where these two intersect here because they are solid lines. That could be a solution. All of these count as solutions. There is one special case that I do want to talk to you about. You may see every once in a while. I'm not going to put exact, I won't put exact names to it so that we're not talking about specific equations here, but you may have a grid just like this, and you might have, we'll stick with the red and the green so that you can see the colors when they overlap. You may have a line here like this. Let's say we'll call it y is, I'm going to just kind of make something up, less than or equal to 3x minus 3. Okay, less than equal to says solid line. Perfect, great. And it says that less than means we shade everything underneath. So all of this, including where I wrote that, everything underneath is going to get done. You might get a green equation. I was going to try this out now. You might get a green equation. Holy crap, it works. Guys, we're learning together. You might get a green equation. Let's call that equation y is greater than 3x plus 3. So same slope. When you remember, if you have same slopes, that means they are parallel lines. They're just on different intercepts at this point, so they're running kind of next to each other. And it's greater than. So it's going to get everything above it is going to get shaded. Well, if everything above that line is shaded and everything below this line is shaded and they're running parallel, so they're never quite going to touch. They're just going to run next to each other forever. There's no overlap. There's no part that things will touch. There's no overlap. So we would say that this system has no solution. There is no place where those are going to meet up together. I'm going to leave this back on that screen that we started on, just so you have it one last time. These are the key takeaways. Less than or greater than means you have a dashed line. Less than or equal to, greater than or equal to means that they're solid. They're including those points. Equal to means that they're included. The less thans of either kind, either less than or equal to, they get shaded below, less, lower. Below the line, greater than or equal to gets shaded higher, above the line. They're going to go in the bigger numbers above the line. And your solutions are any points that are in the shading or points that are on the solid line. If it's a system, your solutions are points in the overlap. Or, like we mentioned, if it's a solid line, they can be points on that solid line. I hope that this helped. If it did, let me know. If you have any other questions, let me know, and I will see what I can do for you. And we will go from there.